Hello and welcome to today's webinar, Using Pivotal Cloud Foundry with Google BigQuery and Vision API. I'm your moderator, Jared Ruckel. We have a handful of great speakers teed up for you. Joshua McKenty from Pivotal, Tino Tereshko from Google, Michael Goddard from Pivotal. Let's jump right into it. At Pivotal, we help a lot of enterprise customers think about transforming how they do software differently. That means new programming practices, pair programming, test-driven development, developing new applications with Spring Framework, and Spring Boot, and also deploying and operating those applications live in production with Pivotal Cloud Foundry, and then helping customers iterate through that cycle. And one of the really cool things that we're seeing is customers of all sizes take advantage of these cloud-native patterns and then extending them to the world of data and analytics and doing a lot more with large amounts of data. And of course, Pivotal's not the only company that's helping enterprises do this. There's a great quote you see there from Diane Green, the head of Google Cloud Platform. A company's core advantage is in the applications that it builds. Today, we'll spend a little bit of time going through how Pivotal and Google have combined to make that a reality for enterprises today. And as we think about extending cloud-native patterns with data and analytics, there are really two goals that you need to have: speed and safety. Launching new features quickly in the market is how you win and how you stand out. You want to launch new code in production frequently, several times a day if possible, but you also have to do this without downtime. The good news is that there's a playbook that enterprises can take advantage of to achieve both speed and safety.
And with that, I'd like to introduce our first speaker, Joshua McKenty from Pivotal. Josh, welcome to the webinar.
Great, thanks, Jared. Glad to be here. I get asked a lot to explain what cloud native is, define the term, work with large enterprises that are trying to be more cloud native. And it's not really a single thing. It's actually the unification of a set of different concepts. So I want to touch briefly on what those concepts are. And you can sort of break this down into four ideas. There's a goal for continuous delivery, and Jared was touching on this idea that speed is really what matters here. This is not a new concept, right? The idea behind continuous delivery has been around since 1927, behind the Toyota method. And the goal here is to shorten the cycle between a user, a product manager, a developer, operators, and back to the user again, delivering continuous value. That's a goal. Containers are one of the key technologies that have been introduced, again, more than a decade ago, but really popularized more recently. Microservices looks like a software architecture, but it's not. It's actually an organizational architecture intended to help scale agile practices. And you can think of microservices as being any kind of service-oriented architecture that allows you to run multiple versions of the same component in production at the same time. And finally, DevOps is a set of organizational practices, again, on the operations side that help change the relationship between development and operations. And at Google, they're famous for referring to this as site reliability engineering, or SRE. I don't want to steal any Google thunder, so I won't say any more about that for the moment. Now, cloud native is a lot of work, right? None of this comes for free, and actually there are maturity models that we will look at in a moment when we think of how to advance toward cloud native. But there's a lot of payback here. The first principle to bear in mind is that writing a cloud native app is not about writing to a specific set of APIs. So if you're writing to vendor X APIs, that's not what makes it cloud native. Cloud native is actually the opposite. A truly cloud native application can be run very well on top of, say, Cloud Foundry. It could also be run orchestrated by any other platform in existence. So what you're really adopting here is a set of software development principles called 12-factor. Now that's a set of constraints, and the nice thing about constraints is that they actually help you go fast. You gain a lot of operational efficiencies by doing this. Let me give a simple example. If updating and patching every kind of application in your data center is the same operation. It's always the same type of deploy. In the case of Cloud Foundry, this would be a BOSH deploy. Then you gain the flexibility of writing code in many languages and deploying code using many different data services without having to think about a dozen or two dozen different runbooks, different operational practices. We talk a lot about scale too, and the irony is, and I worked at NASA, which was pretty famous for large-scale challenges, mapping the moon, mapping Mars, and so forth. For most small companies, scale is a problem that they dream of having. But for most large enterprises, scale is a reality of day-to-day business, particularly retail, banking, industrial use cases. The need to go from 0 to millions of transactions per second on, let's say, Thanksgiving weekend is just a reality of doing business at a global scale. So this dream of elastic infrastructure, which sort of solves the problem that startups wish they had, actually solves a very real problem for large enterprise. Now, one of the things about cloud native that is often misunderstood is this idea that containers is the only part you need. And in fact, containers are a useful component, but they don't really make up 90% of what's in a cloud native platform. So think about the typical components that any application stack needs to deal with. You need authentication, both of developers and operators and your end users. You need log aggregation and distribution so that, again, in the development lifecycle as well as in production operations, you can keep track of the health of your application and its behavior. You need to produce an audit trail. You need to load balance and route traffic to many different instances of your application. Whether you're using containers or not, you need to make sure that you're fanning out that traffic appropriately and that you're avoiding any containers or processes that have failed for whatever reason. You need binding between these various microservices, whether that's something like Spring Cloud with Service Discovery Framework, or whether that's simple data service binding and handling of underlying data credentials. And all of these key components are provided by the platform, and they're provided in a way that's standardized, whether you're working in a development environment, whether you're integrating, testing a number of microservices that have just come together for the first time, or whether you're doing a CD deployment to production. Now, there's a push here for consolidating runtimes as well. And ironically, we used to call this the Donnie Burkholt accordion thesis, right? Which is that in every moment in IT, there's a part of your IT stack that's contracting towards standardization, and there's another part of your IT stack that's expanding towards innovation. You need to take advantage of the contraction and drive towards standardization and reduce costs, but you also need to take advantage of the expansion and drive towards innovation and improve performance, but really give your developers and your business teams the opportunity to innovate, to drive a digital business. So the only way to do both of these things at once with the same number of people and the same shrinking budget is really to standardize your runtimes, standardize your operating model, all the way, as much as you can, standardize down to single operating system, in the same sense that we standardize to a single 19-inch rack and a single layer 2 fabric called the Ethernet. I mentioned before that you can't just jump to cloud native. And actually, the journey from heritage or legacy applications towards true cloud native platform is where you can derive a lot of value, right? Just running off to build net new greenfield applications is useful. You probably know where in your business you need to go build new applications, but that's not the whole story. The average enterprise today has probably 300 applications. Some very large enterprises will have tens of thousands. Others will have just a few dozen. But of those 300, there's likely 10% that you could rewrite today. And you could rewrite them and produce a ton of value for the business by taking a cloud native approach from day one. There's a few hundred of those that probably you can leave be. You can look at some minimum amount of refactoring to get them more cloud friendly and perhaps take advantage of some next generation data center consolidation. But really, it's the hard middle ground, the other 70, that are going to deliver the most value for your business. What you're looking to do is to refactor and replatform those to expose the underlying data as data services for new aspects of your business. And this is really where a platform starts to shine. The interesting thing about this digital transformation, whether we're talking about these next generation greenfield applications or the harder, more valuable work of replatforming and modernizing existing apps, is that it's not industry specific. We see insurance companies, industrial and automotive companies, financial services, retail, almost every imaginable business sector is being driven by the digital transformation now. So I talked mostly about the platform runtime, the Pivotal Cloud Foundry layer, the contract that it provides to application developers on the one hand, and the contract that it provides to IT operations on the other hand. And an important part of that second contract is the abstraction against the infrastructure. Cloud Foundry can only be run on top of application-defined infrastructure or IaaS, right? And it can be run on any IaaS in the world at this point, which gives you flexibility to pick the best IaaS for your workload. And particularly in this case, an IaaS that offers really next-generation data capabilities. We often talk about, a famous quote of avoiding doing undifferentiated heavy lifting. But perhaps a more flexible way of thinking about this is where's your business going to derive value? How can you get software development and IT operations on the value side of the line? So rather than being treated as a cost center or being thought of as just another expense of being in business, how can you really bring all of IT onto the upper side of the value line? Andrew Schaefer and members of his team like Casey West are pretty famous for pointing out that doing a good job building a custom OS has never been anything that got the attention of the CEO or the board. In fact, operating systems are so standardized, there's really no point in talking about them. Having a custom operating system is not a way to deliver value for your business, in the same way that having a rack that wasn't 19 inches would be kind of a waste of time and space. And we see every year the value line in IT is moving up the stack. So there was a point in time where you could deliver differentiated business value by building your own container orchestration, or by designing your own network switches, or perhaps a custom network protocol. But those days are long past. These days, the place where you can deliver value for your business is in custom applications, and particularly in customer-facing custom applications. So not only is virtual machine orchestration, container orchestration, the full of cloud-native platform orchestration, including log aggregation and routing and load balancing, really below the value line, not worth doing in a custom or bespoke fashion. You really don't even want to. The proliferation of snowflakes in IT is one of the biggest cost drivers in the modern data center. So if we think back to that accordion that Donnie Burkholz is always talking about, what is it that's the area of innovation for your business? Probably it's IoT. It's mobile application development. It's next generation data service APIs. And I really want to emphasize that last point again. The data that you can derive from your existing legacy data sets and that you can combine with new and modern data sets is going to be the lifeblood of your digital business. So what we really want to focus on today, what I'd like to hand off to Google to talk about, is how you can use some of their next generation data technologies to take advantage of the data you already have in your business, probably that you're just storing in some data swamp in the corner. So Jared?
Yeah, thank you, Josh. Great overview of cloud native. And now right on cue, we'll take a look at how those patterns can get extended with those next generation data services APIs. So welcome, Tino from Google, to the webinar.
Thanks for having me, folks. I'm really excited to be here and to discuss collaboration between Pivotal and Google Cloud Platform. When I talk to enterprises, generally hearing stories that as mentioned before, it really doesn't matter what kind of racks are in their data centers or what kind of cooling equipment they're using. It really matters whether if you're a content company, how quickly can you deliver content to the right people? Or if you're a media company, how quickly can you produce media content and really have the maximum impact to delight your users? So things like underlying infrastructure can sometimes be distracting, and that's why Pivotal and Google Cloud Platform come in to ease that burden and to really help accelerate pace of innovation. In case of Google Cloud Platform, we have, as you can see per the slide, we have a number of different services. Some of them are really, really low level, like Compute Engine and Google Cloud Storage, that allow you to run virtual machines and storage systems on top of Google's data centers. And Pivotal is building services on top of these building blocks. And really, the reality here is that Google has been running these types of services for the past 15 years at scale, at Google scale, with multiple services having a billion users. And Google has invested lots and lots of time and money and resources in the development of this core competency. We actually are close to $10 billion in infrastructure investments per year, which eclipses Amazon and Microsoft combined. And so running on Google Cloud Platform can be very, very compelling for enterprises that are trying to get the best in breed infrastructure. And of course, technologies like Pivotal Cloud Foundry help you run that for really the very unique enterprise types of workloads. So today we're going to focus on just a couple of really low, very high level services. BigQuery, which is Google's enterprise data warehouse for analytics, and one of our pre-trained machine learning APIs, Vision API. And you guys are going to see a demo of this one. Well, Google BigQuery has a really interesting history. It runs on top of Google Dremel, which is just a massive internal analytics database that's been around since 2006. You can actually go online and look at the Dremel paper and kind of figure out how it runs. It's very interesting. And a lot of the open source projects like Presto and Impala and file formats like Parquet take note of the Dremel architectures. I'm going to be brave and I'm going to try to do a live demo of Google BigQuery. So this is the BigQuery UX. It's a web-based UX. And it's just one of the many ways to interact with Google BigQuery. You can, of course, leverage any of our partners like Tableau and Looker. You can plug in Excel, Google Sheets, or you can use APIs or Python, Java SDKs, or command line tools. So just a variety of access points that a typical analytics data warehouse would have for you. What you see here is on the left side all the different projects that I have access to. There's lots of stuff going on. And we're looking at the BigQuery petabyte project. Inside of that project is this retail petabyte data set. Think of a MySQL schema or a database. And if I'm going to click on this triangle here, I'm going to see a shared data set point. If you've seen BigQuery's public datasets program, which is really fascinating, things like GitHub and Hacker News and weather information are available for you to query today. This is exactly how we do it through access control lists. So I can add anyone with a typical Google ID to this dataset. Or actually, I can say all authenticated users are able to access this dataset. So it's a very flexible access control list. What this gives you is essentially what Google Docs gives you when you need to share a document with somebody else. Instead of making a copy of that document and sending it to someone, you simply share the document with them. And I can do this with really petabyte scale data sets with BigQuery. So let's go to this table. It's called sales partitioned. It's a very typical schema for kind of like a point of sale style data set. And as you see here, there's actually a nested schema here. So this sales order lines is a repeated field, like a JSON-like structure. We actually generate this data set. It's not a real petabyte scale data set. but it does have over a petabyte of data in this table. And that looks like about a trillion rows in this table. So it's a fairly large table. And I should tell you that this table doesn't have any keys or indexes or anything like that. So I'm going to go and look at a query that I can run on top of this table. This is a typical query that I generally run to demonstrate the power of BigQuery. So I'm going to press run. And while this query is running, I'm going to talk about a little bit of what's going on here. So this query has just a fairly large join. It has a partition or a window function. It has a regular expression as well, right? So lots of stuff going on here. And it looks like it finished in 14 seconds. So the only thing that we're really doing here to cheat is we are selecting 1 month out of 3 years worth of data. We're using a 1 month partition. But we don't have any keys. We don't have any indexes whatsoever. We've done nothing to this data set to make it go this fast. We simply loaded the data into BigQuery, and we executed this query on top of it. So let's talk about what just happened in the live demo. This is a fairly complex query that really requires lots and lots of resources to process. In this case, for this query, we know that we actually leveraged about 3,000 cores to get this information out to you in under 20 seconds. What really this means is that you were able to rent 3,000 cores from Google for just 20 seconds. You can think of this as, in infrastructure as a service terms, you were able to go from 0 cores to 3,000 cores and back to 0 for just 20 seconds and essentially pay per second, which is just fascinating to think that these are the possibilities that are in front of you. And on top of that, we only paid $20. So we paid for this query alone. We only pay for the resources that you consumed, which is really efficient in terms of cost. But most importantly, we don't really care that this level of complexity happens under the hood. What we care about is the delivering analytics, running SQL queries on our data sets, understanding the shape of our data set. That's what we really care about. We care about providing value to our end users. So all the complexity is hidden away from the end users. They simply load data into BigQuery. They don't need to do any kind of database administration tasks. They just run queries on top of that data, and results come back quickly. So I hate to use the term democratization, but really BigQuery has really lowered the barrier of entry into very large data sets to really anyone who has these types of data sets. You don't need to be an expert in big data to run big data analytics. BigQuery lets you do that. It's really the commoditization of big data. So what is BigQuery? It is a fully managed, no-ops data warehouse. These terms are used fairly broadly, very widely by different type of vendors all around. But in terms of BigQuery, we really take this seriously. What we mean by fully managed is that we're pushing features constantly, and I'll show a graph later on what this looks like. We're pushing features constantly in real time to our end users. Our end users actually a lot of times don't know that we're pushing new features to them until we tell them in the marketing announcement. Our SREs are on call. SREs were mentioned earlier. Our SREs are on call 24/7, solving problems, looking at error rates, looking at degradation of performance or whether a data center is going down, and mitigating all these risks in real time to just to have maximum uptime, really. In terms of the no-ubs word that tends to be used fairly frequently here, BigQuery really commoditizes all that stuff. You don't need to deploy hardware. You don't need to do provision resources or anything like that. You simply, again, load that into BigQuery, and you run SQL analytics on top of that. And as I demonstrated, this works quite well at petabyte scale. In fact, BigQuery's largest customers exceed 100 petabytes in data stored in BigQuery. It's a fairly large-scale service potentially, but also a fairly effective service for the small-scale use cases. The BigQuery free tier of pricing allows you to run up to 100,000 queries per month for free if your data set is small enough. As I demonstrated, BigQuery supports fairly complex SQL. We actually went general availability with standard SQL, fully compliant to 2011 standards. And the one little known fact about BigQuery is that it is durable and highly available. What I mean by that is BigQuery is deployed across multiple data centers just so we could guarantee higher uptime. This is an interesting slide here. The vertical axis shows you how many features or code submits we release every single month. And it looks like we're up and to the right, which is a good thing, and we're exceeding 1,000 code pushes every single month at this day. And the blue rectangles are generally the really big things that we released. Some of those are like capacitor you see here. It is a rewrite of our storage engine. And DremelX is a complete rewrite of our Dremel execution engine. So these are really significant developments in the history of BigQuery. The really fascinating thing here is that all these features come out without you ever having to push a button to restart your service or to reload your data, to reboot, to resize, or anything like that. You simply get these features seamlessly without any downtime. The queries just run better, your service gets cheaper, more efficient, and so on and so forth. So I encourage you to take a look at BigQuery, especially at public data sets. It's a great way to get started. You can examine the popularity of different projects on GitHub. You can even look at real-time weather data, and among many, many other data sets. And I'm going to briefly touch upon our machine learning services. A lot of these are actually higher level pre-trained services that you can leverage today fairly easily. At Google, machine learning has really taken off over the last few years. Again, the chart on the left is up and to the right. It's just ubiquitous inside of Google, very, very popular. And the vast majority of the big products that Google now has leverage machine learning in one way or another. And one of my favorites that I'm using every single day is Google Photos, which really transforms the way you manage photos, transforms the way you storytell entirely through machine learning. Right? It knows how you interact with the world and helps you narrate that to the rest of the world. And potentially some of the really civilization-changing technologies like self-driving cars that are entirely, or in many ways, machine learning driven, that couldn't have been possible otherwise without this level of technology. So the Google portfolio of machine learning technologies that you can use today is twofold. On the left side, you see that we have 4 different pre-trained models that are exposed through very easy-to-use RESTful APIs. There's the Translate API, Vision API, natural language, and speech. You're going to see a demo of the Vision API. Essentially, with that service, you can send an image to our RESTful endpoint, and in return, you get a JSON that gives you a little bit of information. Things like facial recognition, things like sentiment analysis of the faces, the type of mood you're in, or maybe a landmark, whether it's Eiffel Tower, or maybe things like you're on the beach looking at a sunset. All these things can be returned through this service. And on the right side, we have managed TensorFlow. So if you're a power user who wants to train their own models with their own data sets, Cloud ML is potentially for you. It's a really interesting service. I encourage you to look at it. Great. Back to you guys.
Thank you, Tino. Great demo and great explanation of some of those high-level services with GCP. And Tino, you mentioned that Pivotal and Google have been doing a lot of co-engineering together to bring Pivotal Cloud Foundry to the Google Cloud Platform and also extend those higher-level services through a service broker so that customers can consume Google services from their PCF deployments. That's a very exciting combination. And now during the last part of our webinar, I'd like to introduce Michael Goddard, who will be going through a sample application that's actually running Pivotal Cloud Foundry on top of Google Cloud Platform and using some of these data services. The sample app that Michael's put together is called a Landmark Vanguard. Michael, welcome to the webinar. Why don't you start by talking us through the nuts and bolts of the application, how you authored it, and some of the things behind the scenes here.
Thanks, Jared. Let me show you this application called the Landmark Vanguard application. This is a collaboration between a couple of us at Pivotal, Matt Ross and me, and Dana Hoffman and Eric Johnson over at Google. So we all kind of teamed up to try to show you an example how you might blend these technologies together. So it's pretty simple. A user who has a picture of a landmark chooses to upload their image, and once that's uploaded, we run through some analytics. First, we resize the image for input to the Vision API, and we run the Vision API's landmark detection capability. And if that doesn't detect a particular landmark, we fall back to a different API called labeling. Then we take the output. If we did detect a landmark, we take the landmark name and we send that to BigQuery and run a query against an public data set to find books that are related to that landmark. And then we also plot the location of that on a Google map. And so that's all we're doing. And to get started, we decided to make a Spring Boot app. So we went to Spring Initializer at start.spring.io and we said, generate a Maven project, and we gave it some coordinates for our Maven POM, and we said these are called Spring Boot starters, and we took the web ones. So far there are no Spring Boot starters for Google Cloud Platform, but we anticipate those will kind of emerge in this ecosystem fairly quickly. This is the GitHub repo for Spring Boot starters, and you can see here there are a lot of those. And what they do is they add the dependencies to your POM to automatically pull those in for you, so you don't have to worry about that. So once we click Generate Project, the browser downloads the zip file, and then inside of the zip we have a POM, which we can see once we expanded that. And if we go into our IDE, which I show here, this is the IDE view of the Maven POM file with some additional dependencies added, because we've, at this point we've gone through and built the app out. This is kind of the entry point for the app. It has the main method. This class is annotated as a Spring Boot application. We have Credential Manager. So what I'm going to talk about is part of this involves binding to these services. And when we do a binding, our application gets an environment variable passed to it, which is called vcap services. And within that, we get access to all the credentials that we need to access these various services. So the Credential Manager within our app is how we can access the Storage API, the Vision API, and the BigQuery API. So here we've got the Storage API class, and what we use this for is when the user uploads the image, we take that resized image and store that so that we can later show that to the user as a thumbnail view, or if the user clicks one of the existing thumbnails, we can just fetch it from storage and pass that back into the Vision API. So here's the Vision API service class. So what we're doing here is we're consuming two capabilities, landmark detection, and then if that doesn't detect a particular landmark, we'll go to label detection. And then here's BigQuery. So BigQuery, Tino showed that it supports very advanced SQL, and we're making use of that. We're deduplicating because some of these books over the years are duplicated. So we're using a window function to dedupe the results there, and we're also using a regular expression to do a better job at kind of fuzzy matching the name of our landmark. So the other piece of this is in order to do this resizing, we thought that maybe Python would be better. And it turns out it was really quick to make a Python Flask app that has a resize method and just takes advantage of a library called pill. And so we decided to do that. So we created an image resizing microservice. And if you don't know this, one of the big benefits of Pivotal Cloud Foundry is that it has build packs, and that enables it to be a polyglot platform. So in addition to Java and Spring Boot, we are able to deploy Python app. And there's just a huge number of build packs, and there are several built in here. And you can just pull some down from GitHub if you want. You can even push a Docker image if you like. So it's very flexible. I'm going to take you here to Ops Manager. This is the operator view of Pivotal Cloud Foundry. So each of these, we call these tiles, controls a different aspect of the platform. So we have 5 of these here now. This one controls the IaaS, so we're deployed on Google Cloud. This one is the tile for the Google Cloud Platform Service Broker, and that's going to be how we expose a marketplace of Google Cloud Platform services, which our app is going to consume 3 of those. And so note here we also have a new tile. It's a Kafka one. And in the future, I think we're going to look to extend this demo a bit to take some of the user interaction data and publish that into or produce to a Kafka topic so we can do some analytics on that data. So keep in mind, even though we are deployed here in Google Cloud Platform, that the Google Cloud Platform Service Broker would allow us to access those services regardless of which IaaS we're deployed on. Could even be on-premise, and we could, on-premises, and we could access those services. This is Pivotal Apps Manager. This is the developer view of the platform. So right here it's showing I have 1 app deployed, 3 services or service instances. So I have 1 instance running of the image resizing service. And I'm just going to show you one way to scale that up. When this app is running and multiple people using it, we probably have a bit of a load on the resizing service because it's going to resize all those thumbnails on the fly in addition to each of the images that gets uploaded. So when I just increase the number of instances to 4, that results in basically we get a load balanced round robin effect across all these instances. So we get load balancing, which is great. Let's take a look at our services. So right now, we have some service instances already there, BigQuery, cloud storage, and then a user-provided instance to our resizer. But we want to add a machine learning vision API instance. So I'm just going to click through that and make an instance of that. Probably should call that vision. We're going to put it into the dev space. I'm doing all this in development. And we're not going to bind it to an app yet because our app hasn't been pushed just yet. So now we've created that service. The next thing, in order to get our app up and running, is I'm going to need to do a Maven build of my app. And that's going to go through, compile that, and create a jar file after all the tests have run, if they all pass. So right now we're running a couple of queries in the tests. We're doing a couple of image recognition. So it looks like we recognize Tower Bridge and Taj Mahal. And now we have the unit of deployment here, which is the jar file for a Spring Boot app. So what I'm going to do right now is go ahead and say CF push, but don't start this app. So it'll be out there, and then the next thing we're going to do is bind a service here from the command line. So I'll show you how to bind the storage service to that app. In just a second, all that has to do is load. So now I say bind service. The landmarks app being bound to the storage mic instance of cloud storage, and it's going to be bound with the role of editor. And the next thing we're going to do is say CF start landmarks. So while that's starting up, so basically what's happening is the jar file is already there, and the runtime has to be built up, and that requires the JRE, and then that's going to create what we call a droplet, which will be something that we can start up within Pivotal Cloud Foundry. So right now I want to just point out real quick, we have 5 tiles here right now, But if we wanted to, we could import more services pretty easily. We can import a product once we've gone to Pivotal Network and signed in. If you look here, these are it gives you an idea of the ecosystem of services for the platform here for Pivotal Cloud Foundry. And a lot of these are partner services where we've got everything from Apogee, App Dynamics, we've got data services, and then here, of course, is our Google Cloud Platform Service Broker. So it looks like our app is running. So now we have an endpoint here. This is the URL that our app is running on. And let's go back up here. And okay, I already have that open. So we'll reload it. So these are 4 thumbnail images that have already been uploaded. I'm going to go ahead and upload my own image. So let me find one. And let's see. We can browse visually is probably better. So this is probably a good one. I know Tino mentioned Eiffel Tower. So let's see. Uploading the image. It's getting resized, sent to the Vision API. When we get a result from that, we'll run a BigQuery. So Vision API detected a landmark, Eiffel Tower, with 50% confidence. The Eiffel Tower is located here. We have a Google map showing that. The Vision API took 8/8 of a second. BigQuery ran in 6.5 seconds across 190 megabytes of data, which is the Internet Archive book collection. Found 2 books. And that's pretty much it for right now. I encourage you to take a look at the source code. There'll be some links provided for the GitHub repos, and hopefully try this out for yourself. Thanks a lot.
Wonderful. Thank you so much for that demo, Michael. Thanks to you for that. And also thanks to Josh and Tino, our earlier speakers, for their time today. Really appreciate it. We've got all the speakers on the line to take questions from the audience. And while you're submitting questions using the console, we urge you to take a look at some additional links we have on the screen here. If you want to know more about Pivotal Cloud Foundry running on Google Platform, getting a trial of this running in your Google environment, taking a look at the service broker, or even looking at those sample repos that Michael mentioned, all the links are there for you on the screen. Thanks again for your time and attention, and happy to take any questions from the audience today. All right, well, thanks everybody for your time. There's a lot of great information on the slide here. We'll get to some Q&A, but while we do the Q&A, we'll speak to I wanted to highlight some of the links we have here. There's some web pages with some information about running Pivotal Cloud Foundry on top of Google Cloud Platform. You can download a trial, the actual bits, take a look at the service broker that Michael just finished up demonstrating. And there's also some repos with the sample app that Mike went through as well. So those are freely available, so go ahead and check those out. The Landmark Vanguard sample application, as well as the image resizing microservice that was a big part of the demo that was shown there. So we've got some time for some questions and answers here. Looks like we've got one here for Michael. What was the development experience like using PCF and Google services? And I think, Michael, this brings up an interesting kind of question, this whole notion of platforms and cloud infrastructure and these data and analytics services. The whole idea is to make life easier for the developers. So what was that like in the real world as you were developing the application?
Yeah, great. As a developer, the experience was excellent. We knew that we wanted to build an app that would take a picture of a landmark and determine what that landmark was, and then further send it into in a query to BigQuery. So basically, we were able to use the marketplace offerings that are provided by the GCP tile and that service broker, and bind our application to those services that we needed. and then that provided the credentials in kind of a uniform way, so that it was the same type of thing, whether we were using storage, the Vision API, or BigQuery, except for what we were doing with each one of those different components. And so it was neat to actually be able to also use it in our IDE and fire up the app there, and then push the app into Pivotal Cloud Foundry and have it bound to those services. And then, obviously, at that point, we're able to share that version of the app with kind of our stakeholders and get some feedback, and then iterate really rapidly by saying what do we need to do next, and how are we going to accomplish that, and then push out the next iteration of the app just using CF push in a really short order, because we had a pretty short turnaround on this, and we had a number of people in a distributed sort of fashion who were all wanting to make sure that we touched on certain different features. So that, for me, the experience is just basically low friction. As a developer, I get to do what I want to do, and I don't need to be concerned with the underlying infrastructure at all. I don't need to worry about VMs or databases or anything like that.
And following up on that, you made this a Spring application. What was it like using Spring? What were the decision process like for using that framework?
Yeah, the thing is we sort of knew that we wanted to do a Spring Boot app, just because from past experience, it makes it so easy to kind of bootstrap your application. You go to start.spring.io, use Spring Initializer, and enter a couple of items, and then get the Spring Boot starters for the web, for a web app. You download this POM, and then you're just off and running, and you can be productive really quickly. And then within Spring, there are so many nice things that you just take for granted that you don't really have to worry about kind of writing sort of scaffolding code. You're really more focused on, what's the business? What is it I want to do? Rather than how do I kind of set up all this this code that doesn't necessarily have a lot of value, because the framework takes care of all that for you. So we were able to really get quickly to where we could demonstrate uploading an image and showing what it was, and plotting it on a map, and then running a query to get the book. That was really exciting, and for us, the Spring framework was just a natural choice, because it kind of accelerates things so much, and Spring Boot in particular.
All right, thank you, Michael. Question here on performance. What sort of performance can we expect out of this combination? How does it compare to PCF on-premises or raw GCP? This is a good question. Performance, I think, is always paramount when you're talking about the rapid processing of data. A lot of real-time scenarios come into play when you're talking about these analytics services. Josh, could you talk a little bit about the performance that I think we've seen out there in the field?
Absolutely. I think there's probably 2 or 3 factors that are worth highlighting. So raw BigQuery performance, or the Vision AI Cloud ML performance is incredibly impressive. I think we saw in the demo querying in a 1 petabyte data store in around 18 seconds. So the underlying Google data services are very high performance, and there's no impact to the performance of those services from using PCF to host your applications. So that's really nice. The way the service broker service binding works, it's not a proxy. It doesn't add kind of any interpretation layer in between the app, and the data service is just really brokering connectivity and credentials. Using Pivotal Cloud Foundry to scale up your data microservices or your applications. We just recently finished a scale test of running 250,000 containers on top of GCP, and not only was that kind of a really impressive sort of scale up, but how quickly we can scale to that kind of volume is just really astonishing. And even under load, under variable load, under kind of a mix of different workloads and different microservices, with high percentages of those even simulated as failing under load or failing in production, the load balancing is really key for high performance of the application overall. So that's been encouraging. One of the things, and I think Tino maybe could speak more to this, but Google load balancing, just the quality of their global networking is just really impressive. And we know that anytime you're hosting Pivotal Cloud Foundry on top of GCP, that's what you're getting as your front-end load balancer is the same load balancers that run, YouTube and Google search. So the performance there is kind of amazing. And even for the way that, Spring Boot applications, the JVM is orchestrated by Cloud Foundry, because Spring Boot kind of takes advantage of almost an embedded JVM approach, this is really kind of the most high performance way to run Java in the cloud these days. It's an optimized operating system environment. It's container optimized for your specific workload. The build pack has been optimized for Spring and Spring Boot, obviously. And so not just on kind of performance of developer productivity and being able to turn out new versions of your application and split it up, the launch time of these instances, the launch time of the underlying infrastructure, the performance of the data tier. When I was working in gaming, and I love to tell these stories, but when I was working in video gaming back in the early 2000s, we used to say that the experience of the game overall was as good as the worst part, right? So if you had really great vertex and pixel shaders, but the game AI was poor or the physics engine was sluggish, the game was going to feel bad. And so I think this combination of GCP and Pivotal Cloud Foundry, we just have a uniformly high bar for performance. And so we're looking at the storage performance and the compute performance and the networking performance and the instance launch time and the responsiveness of the AI layers. And just overall, it's just really, really impressive. I don't know, Tino, do you want to add anything to that?
Yeah, that's a great overview. On the topic of the load balancer, it's really interesting to kind of think about how Google does load balancing. Google has a global network. It's a software-defined network. We lay our own fiber underneath oceans and just an incredible amount of bandwidth. And with that, we have hundreds and hundreds of points of presence around the world. And the way our load balancer works really is it's not a bunch of VMs that are running kind of like an HA proxy or something along those lines. It really is a window into our network. So for example, if you have a customer in New Zealand that wants to access your virtual machines that are operating in Asia or United States, that customer is going to go to the nearest points of presence on essentially the nearest load balancer point of presence. That's probably going to be in Sydney or somewhere really close to the customer. And then through our backbone, will make its way to your virtual machine on Google's network, right? So it's a very different experience than what you're normally used to. And that's why it's really interesting to partner with somebody like Google and partner with somebody like Pivotal to not only provide the best in breed of infrastructure and vast investments in networking, but also the architecture, the manageability layer that Pivotal provides.
Thanks, guys. And Josh, you referenced the benchmarking a little bit earlier, and what really stood out to me about that benchmarking survey is that it wasn't this container engine or orchestrator kind of in isolation. It was really about the entire platform to flex and scale out to handle a real world, enterprise type of use case. It wasn't just sort of one small part on its own that didn't mimic what a real world scenario would be.
Yeah, it was a pretty comprehensive benchmark, sure.
Okay, and folks, if you do have questions, please ask those using the Q&A console. A couple questions here. What are some of the enterprise use cases for BigQuery? And Tino, you mentioned a few there. in the demonstration, you're working with sales, product, commercial kind of enterprise sales data. What else have you seen out there in the field from enterprise customers using this service?
That's a really good question. BigQuery is a very versatile analytics data warehouse. And with that, we see a number of use cases. Really, the biggest one for which BigQuery in general was built for is understanding kind of like how users interact with your applications. And really, there's not a lot of enterprises that can't be considered internet companies by now. And so a lot of ways your enterprise is being interacted with are through the internet, through clicks and impressions, and at the same time through ads. And when it comes to this type of analysis, it can be very compute intensive and it can be very, very storage intensive as well. So BigQuery allows you to be very greedy with your data, to provide a holistic approach to collecting the data. Collect everything, analyze everything. Because things like sampling or just only collecting what's the bare minimum that's necessary is not going to help you understand what customers are doing. So kind of like the clickstream analysis type of analyzing how your users interacting with your ads is a huge use case. At the same time, we're seeing customers like Ocado, which is a very interesting customer out of the United Kingdom, are leveraging BigQuery for their operational intelligence, analyzing transactions, analyzing point of sales, analyzing their supply chains, and so on and so forth. So it's a very traditional brick and mortar style use case. And beyond that, we have a number of use cases in IoT, telemetry to data, of course, gaming, and we're very, very popular in the genomics space as well.
Get greedy with your data. Really, really like that. All right, looks like we've got time for one more here. What about lock-in? This is kind of the boogeyman that IT folks have talked about for a while. Josh, would you take this one about how to think about vendor lock-in with open source tools like Cloud Foundry and with IaaS providers like Google?
Absolutely. And I think, obviously, Cloud Foundry has always been designed to run across multiple infrastructures on-premise and out in the cloud. And one of the key interfaces that we use as part of the 12-factor contract is this idea of service brokers and service binding, which is really how individual applications connect to data services, whether they're on-prem or off-prem. We've worked really hard in the Cloud Foundry Foundation to promote the service broker interface as an open standard, and we've seen a lot of adoption now of that standard across other container orchestration communities, and a lot of collaboration with folks at the CNCF as well. And so we're now starting to see this real advantage that the way that these Google data services are exposed into Pivotal Cloud Foundry, the service brokering, service binding, can also be supported if you were using other container orchestration approaches. And so this notion that your applications, when they're written to be cloud native, are never written to the API of the orchestration layer, right? So if you write this application, for instance, if you look at the way this app is written, there's nothing in that app that makes it only run in PCF. You could actually take that app out and you could run it in raw virtual machines, or you could run it in some other orchestration framework. And as long as you had something that was running as a service broker, that service broker and binding could still work. So that's, on the application, you want to preserve that kind of portability. You can use Cloud Foundry to do that. You're not writing natively to a Cloud Foundry API from your applications. And you're really using the data services for their kind of next generation capabilities. And maybe I could hand it off to Tino to talk about kind of the TensorFlow and the community around machine learning that's growing up and how these models work, if that makes sense. But I think the boogeyman has been pretty much debunked at this point in terms of portability on the application side.
Yeah, that's it's a very interesting topic, especially within the context of cloud native. I think historically in the past, folks were afraid of vendor lock-in because of just the situation they found themselves in. They had very long-term contracts with hardware, and of course, hardware lock-in is kind of hard to get around when you actually own hardware. And of course, you had vendors that would make you sign very long-term contracts. I think what we're seeing in the cloud today is that not only are technologies more portable, they're also much easier from a business standpoint. It's not very hard to not find yourself in a long-term contract. And of course, with things like TensorFlow, things like Pivotal Cloud Foundry technologies, you're seeing open source being a first-class citizen. So you could potentially run all these technologies on premise or wherever you please. But then a company like Pivotal helps you run them at enterprise grade.
All right, wonderful. Thanks everyone for your time today. Thanks to our presenters for the valuable content. Thanks to Michael for the demonstration, and thanks for sticking around for the Q&A. Handful of resources for you there on the screen as you've been looking at for the last few moments. Definitely encourage you to try out those links, try out the sample app, take a look at some of the bits we have available for download. And also Pivotal and Google are here to help you on your journey to cloud native and taking advantage of some of these patterns that were discussed on the webinar today. So with that, we look forward to working with you in the future, and we'll see you next time. Thanks, everyone.
Thank you.